The offside rule in association football is written as a geometric absolute. A player is either behind the offside line or they are not. There is no gradient and theoretically no room for interpretation. But on the pitch, this geometric perfection clashes with human biology. For over a century, referees have had to enforce a millimeter-precise law using nothing but unaided human vision. To enforce this absolute binary, the sport introduced the video assistant referee, or VAR. The goal was to replace human estimation with technological certainty. The issue is that both systems, unaided human perception and high-speed optical video tracking, are restricted by their own distinct systemic limits. Exact offside measurement is currently an illusion. It masks deep neurobiological and technological constraints beneath a veneer of precision. To understand why the offside rule breaks down, we have to analyze the mechanisms of failure across both the analog and digital eras of measurement. In the pre-technology era, the primary limitation was a biological glitch in the visual cortex known as the flash lag effect. Today, the VAR era is plagued by a mathematical flaw called spurious precision. By synthesizing human error data from the 2002 World Cup with 2022 optical motion capture studies, we can isolate exactly where these systems fail. Until we map these constraints, we are applying the rules of the game to phantom data rather than physical reality. We begin with the baseline test of unaided human officiating, a dataset of offside decisions analyzed by Werner Helson's team during the 2002 World Cup. This chart shows correct versus incorrect offside calls verified by digital video. Out of 337 offsides, the error rate was 26.2%. Look at the distribution, a massive skew. 86.6% of mistakes were flag errors, false positives, while 13.4% were false negatives. At the time, the prevailing explanation was the optical error hypothesis, which argued that assistant referees were simply caught at bad viewing angles. This schematic charts the referee's physical positioning relative to the offside line. For correct calls, referees were an average of 0.81 meters ahead of the line. For incorrect calls, they were 0.77 meters ahead. The positions are virtually identical. A difference of just 4 centimeters in physical positioning cannot account for a systemic bias toward calling onside players offside. The geometric positioning of the official on the pitch is largely irrelevant. The error is being actively generated inside the referee's visual cortex. Neural activity takes time to travel from the retina to the brain. This creates a latent delay between an event happening and a human perceiving it. To prevent us from living perpetually in the past, the neural system compensates for transmission delays by smoothly extrapolating the forward position of moving objects. This system works well until it hits a specific psychophysical trigger, a continuous motion tracked alongside a sudden, unpredictable, discrete event. This illustrates the flash lag illusion. A continuous trajectory line is the sprinting attacker. A sudden flash represents the kick. Since the kick is unpredictable, the brain compensates, forcing the continuously moving attacker forward, perceiving them spatially ahead of their true position at the flash. Evolution hardwires human beings to see a sprinting attacker further forward than they actually are. Due to the flash lag effect, unaided human referees are physiologically incapable of accurate offside measurement. Video assistant referee technology was introduced as the objective solution to eliminate this biological lag entirely. However, cameras do not capture a continuous objective reality. They capture discrete, static frames. This timeline models a standard semi-automated offside camera. It operates at 100 frames per second, meaning each frame spans exactly 0.01 seconds. While 0.01 seconds sounds instantaneous, an elite sprinting attacker covers several centimeters of physical distance in the dark space between those two frames. The exact millisecond the ball leaves the passer's foot almost always occurs in this unrecorded void between frames. Millimeter-precise VAR lines we see on television anchor to this deeply flawed, subjective human timestamp. A multi-million-dollar optical array is ultimately invalidated by a fraction of a second of human estimation error. In an attempt to bypass the controversy via legislation, former manager Arsene Wenger has proposed the daylight rule. Under this proposal, an attacker is deemed onside if any scoring part of their body is level with the last defender. Shifting the offside line to the back of the defender changes the threshold, but it fails to solve the underlying physics problem. Officials must still use the exact same flawed inputs, unrecorded frame gaps, and subjective human timestamps to make the call. We rely on the unaided human eye, or a 100 frame per second camera. We are attempting to extract absolute precision from systems strictly bound by latency. To align the sport with physical data, football must abandon the illusion of millimeter perfection. The mathematically sound solution is to introduce a 10 to 15 centimeter tolerance zone into the VAR system. Giving the benefit of the doubt to the attacker inside this specific zone perfectly maps to the physical limits of our tracking tools. A calculated tolerance zone is not a compromise. It is a strict scientific requirement reflecting true measurement boundaries.